Don't you guys feel bored?
I know, right? I'm just bored to scroll my phone.
You know, it's so suffocating just stay in our room 24 hours. Let's just do some fun activities to do since week 14 is stressed the hell out of me.
True. Do you know any fun activity to do?
I do. Hehehe, I have some cool stuff to do.
Whoa! Whoa! What was that?
Balloon? Yes. Just follow me. Let's help me see this balloon. What the? Whoa, so big. Wouldn't it be great if we have bigger balloon?
Oh, I just remember I have something too. Okay.
Whoa, that's cool. It's bigger than I expected.
Me too.
I kind of wondering how big can it go if we fill up this balloon with water?
I'm also wondering how long the time to take to fill up this balloon.
If you guys wondering, let's find out. Whoa, since the balloon is as big as this bucket, I think the diameter or the radius might be same as this bucket.
In order to solve the problems, we need to use related rates. Let me introduce what is related rates. Related rates problem involve two or more variables that change at the same time, possibly at the different rates. If we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one is changing. This usually involves writing an equation relating the two variables and taking the derivative of the quotient with respect to time. Next, why do we use related rates? We use related rates in order to figure out how fast one variable are related and how one of them is changing. These are changed at the same time but possible at different rates. How to do related rates? So, here is the step in solving related rates. Step 1. Writing down the quantities that are given and need to be determined and make a sketch and include essential labels whenever possible. Next, construct an equation that related both the constant and variable quantities, and then apply implicit differentiation to differentiate the question. Next step is substitute all the values that we have from step 1 and then find the unknown rate of change. Lastly, review the problems and make sure all the questions were answered. Nursyuhada brought a big spherical balloon. Then it was filled with water, and assuming that the balloon is filled at a rate of 24.37 cm³ per second. Aqilah, Dinie, and Nursyuhada is wondering how fast is the radius increasing when at certain radius. From the situation, the circumference of the balloon is the same with the bucket, so that the radius and diameter also the same. The diameter of the bucket is 28.5 cm.
Okay, for problem solution, a big spherical balloon is filled with water at a rate of 24.37 cm cube per second. How fast is the radius increasing when the diameter is 28.5 cm? From the question, we already get the information of dV over dt equals to 24.37 cm cube per second, and the diameter is equal to 28.5. From the diameter, we can divide by 2 to get the radius. The radius is equal to 14.25 cm. From the question, we wanted to find how fast the radius is increasing, so that we know we want to find dr over dt. By using chain rule, an equation has been created that is dr over dt equals to dr over dv times dv over dt. dv over dt already given, and we must find dr over dv. By using spherical formula, that is 4 over 3 pi r cube, we must differentiate it to dv over dr. dv over dr equals to 4 pi r square. From the equation, we need dr over dv, but we got dv over dr, so we must change the place to dr over dv. So dr over dv equals to 1 over 4 pi r square. So in the chain rule, we substitute dr over dv with 1 over 4 pi r square, and dv over dt equals to 24.37. In the question, we need to find when the radius is 14.25, so we substitute in the equation. So dr over dt, we got 9.5503 times 10 power of negative 3.
The conclusion is balloon is a sphere shape that is expanding at a constant rate. The rate of the volume of the sphere balloon is increasing as well as the rate of the radius of sphere balloon is increasing. Both of these values are increasing due to the expansion of the sphere balloon, and their rates are increased. Thus, related rates are rate of change in volume is related rate in radius. Hence, dv over dt and dr over dt are related rates because volume is related to the radius.
Wow, that's big. That's big.
Okay.